Good morning. Today we are going to finish section 2.6, and we're talking about derivatives of inverse function. The last video was just specifically derivatives of the inverse trig functions, but now we're talking about just any inverse function. So, quick review on what an inverse function is and what properties it has, and then we'll see it's really how the derivative of a regular function is related to the derivative of its inverse. So, here we go. Here are some things that you, I think, should know about inverse functions. That the notation that f of x and f says like -1 of x, you have to recognize that that means the inverse. And you have to know that the second point there says for any ordered pair, a comma b, that's on the graph of the original function, then the point b comma a is on the graph of the inverse. So if the point 8, 4 is on the regular function, then 4, 8 would be in the inverse. And then as far as the graphs of inverses are concerned, you should remember that they are in fact reflections over the line y equals x. So now I guess I'll also remind you, in years past, you would have done some algebra to find an inverse. Like if it gave you a function and it said find the inverse, you may remember you switched x and y and you solved for y. We're not going to have to do that for derivatives, it turns out not to be necessary. But that might ring a bell as far as something you learned about inverse functions. And I just have a graph here on this next page, I have a graph of two functions. One is x squared, which is just a parabola. And the inverse of that is the square root of x, which is the sideways parabola. So I just want to point out that those two, the blue parabola, the red parabola and the blue sideways parabola, are in fact reflections over the line y equals x, and that dotted line there is the line y equals x. And I just put the point, I just highlighted the point 3 comma 9 on my original graph, and obviously 3 squared is 9. And then just as I said, if the point 3 comma 9 is on the original graph, then the point 9 comma 3 is on the inverse graph. So just that relationship is worth being comfortable with. Okay, so now what we want to do is, we want to look at derivatives. So we're going to look at those two graphs, x squared and root x, and we're going to in particular look at the point 3 comma 9 on the original graph and the point 9 comma 3 on the inverse, and we're going to find what the slopes of the tangent lines are. And it turns out there's a relationship that's going to help us find any inverse derivative. So here we go. So first we're going to, in blue here, we're going to find the slope of the graph of f of x equals x squared at 3 comma 9. And then in red, we'll find the slope of the inverse at 9 comma 3. So what we're looking for here is, what we're going to calculate here in a second, this is not going to be neat, I apologize, is the slope of that tangent line I missed and the slope of that tangent line. Like there's a relationship between those two slopes. So let's find those two slopes. All right. So, well, this one in blue, this is an easy derivative, right? If f of x is x squared, the derivative is 2x. And f prime of 3 would be 2 times 3, which is 6. So it turns out that this line right here, the slope equals 6. That's the slope of that tangent line. All right, that wasn't difficult. Now let's get my picture out of the way. Now let's find, for the inverse function, which is the square root of x, let's find the slope of the curve at 9 comma 3. So as you would, I rewrote the function as x to the 1/2. There it is. That's just rewriting it in such a way that I can take the derivative. And now, of course, let me show you that right there. There's the notation for f inverse prime of x. And it's awkward notation. I'm aware of that. Just got to be careful, and you can't be too sloppy, or all the negative and the 1 and the prime all look alike. So be careful. That's the notation for f inverse prime of x. So let's just take the derivative of x to the 1/2. Well, I know that you all know that is 1/2 times x to the -1/2. That's just using the power rule. And then I might rewrite this, and we've seen this derivative before. This, I believe I could write as 1 over 2 times the square root of x. All I did was the 1/2, I moved the 2 to the bottom, and the x to the -1/2, it's on the bottom as x to the 1/2, which means the square root. So there's the derivative of that function. So now, again, we're plugging in the x value, which here is 9. Remember, it's backwards. Down the other one, the 3 was the x. Here, the 9 is the x. So now the question is, what's the slope of that particular line? Let's just plug in 9. This is 1 over 2 root 9, which is 1 over 2 times 3, which is 1/6. So it turns out that the slope of this line is 1/6. And I'm asking you to probably, obviously already, look at the relationship between those two slopes. There it is again. This time I actually drew the line neater, drew the tangent lines. Slope of that line is 6. Slope of that line was 1/6. And that relationship holds. And that's important, that if the slope at AB is something, 6 in this case, the slope of the inverse at B comma A will be the reciprocal of that 6. The reciprocal of 6 is 1 over 6. So there's the conclusion. The slope of f of x at A comma B and the slope of f inverse of x at B comma A are reciprocals. And I think that's fairly obvious from that picture. Okay, now we have a formula that we're going to use that, at least at first, will look extremely confusing. And I need to tell you to keep in mind that all this formula is saying is this sentence right here, that the slope of the inverse is the reciprocal of the slope of the original function. So let me go to this thing here. So there's the formula for the derivative of an inverse function. F inverse prime of x equals 1 over f prime of f inverse of x. And I completely agree. That sounds, I have no idea what that says. That's a lie. I do know what it says. But I need you to I need you to understand by the time we're done what that says. So really, this is saying, if I want f, not in yellow, that'd be silly. If I want f inverse prime of 9 of the function we just did, that'll be 1 over f prime of 3. Like that's what we just did. We found the slope of the original function at 3, which turned out to be 6. We just took the reciprocal of it to get our derivative of the inverse at 9. So that's kind of what we did. Now, we didn't do it. We found the slopes of the 2 points, and we observed that they were reciprocals. But I'm telling you, that relationship holds. So if I want to find f inverse prime of something, all I have to do is find the slope on the original function and just take the reciprocal of it. Okay, so that doesn't sound bad. Again, really the only issue here is the notation, is understanding what it's asking you to do, because ultimately you're going to take the derivative of a function, you're going to evaluate it at an x value and get a number, which will be a slope, and you're going to take the reciprocal of that. Like, that's the process, and that process is not bad. But now I'm going to figure out, there's one trick, is the wrong word. There's one thing that confuses people. So let's look at an example. It says let f of x equals x squared minus 11. And it says find f inverse prime of 5. There's one thing that's missing from this problem, and you need to recognize that it's missing, and you need to know that you need to find it. So I think I'm trying to explain this here. This says this means the point 5 comma, I don't know, is on the graph of f inverse. And obviously I wouldn't, if I had a function for f inverse, I could take the derivative and just plug in 5. I don't have that. So if 5 comma I'm not sure is on the graph of f inverse, that means the point I'm not sure comma 5 is on the graph of f. We need to apparently turn the light back on. I'm gonna wave to myself over there. Here it comes. So again, you need to recognize it's going to give you a function, f of x equals x squared minus 11. Gives you the original function. And it's going to ask for f inverse prime of a number. In this case, it's 5. You have to know that that 5 is the x value in the inverse, which means it's the y value in the original function. And we need to know what x value goes with 5. So we need to figure out what number is it on the original graph that is something comma 5. Because that number is what we're going to take the derivative of f and plug it in, and then eventually take the reciprocal of. So it kind of looks like this. I'm not going to do the whole problem. Let's go back to what we just did. What if I was finding f, and I'll come back to this problem in a minute. F inverse, actually let me change letters here so it doesn't confuse you. Okay, I'm going to come back to this one. Let's say g of x, let me go back to my pen, sorry. Let's say g of x equals, let's say I was just using that function, and I wanted to find g inverse prime of 9, which is really what we did. We found there's g inverse, the point is 9, so we were looking for that. Well, we need to know the point, what comma 9 is on the function. So we would actually have to set this equation equal to 9 and solve it. So x would equal 3. If you get a plus or minus, if you get a couple answers, you can really use either one. We're going to stick with the positive one. So there's a number that, the way I worded this problem right here, the problem didn't give you. It just said find g inverse prime of 9. You needed to know the find 3. Once we find that 3, well, then we take the derivative of g of x, which is just 2x. We plug in 3. 2 times 3 is 6. And we take the reciprocal of that, which is 1/6. So we did all that earlier. So you just kind of have to know that we need that. It's not going to give us, like in this one, we had the point 9 comma 3. Normally, it's just going to give us that 9. We're not going to know that it's 9 comma 3. We're going to have to figure out that it's 9 comma 3. So that's not where I was. This is where I was. So now let's go back to this problem. So we have to figure out what the question mark is. What number is it? On the original function, it's something comma 5. Once we know that number, we'll just take the derivative of x, which of course that's an easy derivative to take, and we'll plug in this number that we still have to find, and we'll just take the reciprocal of that. So, all right, to figure out what this question mark equals, we need to set the original function equal to 5 and solve for x. So in this case, easy equation to solve. I have x squared minus 11 is 5. I add 11, I get x squared is 16. I square root both sides, I get x equals 4. Again, if there's plus or minus, we're going to stick with the positive unless the problem tells you otherwise. So it turns out that the point 4 comma 5 is on the original function, f of x, which means the point 5 comma 4 is on the inverse. So we have to know to find that 4. Now let's find, did I do it here? Oh, no, so there it is. So there's my function. We'll take the derivative, which is still 2x. I plug in that 4 that I needed to find. I get 8. And if f prime of 4 is 8, that means f inverse prime of 5 is just 1/8. So let me back up here to this one maybe. Nope, to this one maybe. Nope, to this one. No, I'm looking at this set right here. You have to, if it asks for f inverse prime of a, of some number, you need to set the function equal to a and solve it for x. And the problem will not tell you that you need that number, but you do need that number. In this case, the number we were looking for was 4. Once you have that number, take the derivative of the function, plug in the number you just solved for and evaluate it. That's the slope of the original function. And then take the reciprocal of that to find the inverse. Now, this equation, x squared minus 11 equals 5. Come on. Was easy to solve. Sometimes it might be a little trickier to solve, and I'm telling you that, and this, I'm going to come back to this sentence here. It says either solve it algebraically or sometimes just try small numbers. If it's an equation that looks like it'd be difficult to solve, I'm telling you they're not going to give you one unless the answer is like 1 or -1 or 2 or -2 or 3 or -3. So you may just have to try some small numbers to figure out what works. So I have one more example for you, which is this one. I think I did the work. So let me cover this up a little bit. Okay, so here's what this problem will look like. It says f of x equals x plus 3 over x plus 1. And it says find f inverse of 2. So we need to know first that we need to find a number. We need to set the function equal to 2 and solve for x. We need that number. Once we have that number, we'll take the derivative of f of x, which looks like it's a quotient rule. We'll plug in not 2, but the number that we'll find in a moment, get that slope, and then take the reciprocal of that to find our answer. So first step is set the equation equal to 2 and solve for x. So let's do that. There's the what we should do. I think I did it here. Okay, so I solved it. I multiplied both sides by x plus 1, which became x plus 3 equals 2x plus 2. And then I think I maybe subtracted x from both sides. Oh, no, I actually I moved the x's to the left. I subtracted 2x from both sides, and I subtracted 3 from both sides. I just solved it, hopefully a simple equation. I got x equals 1. So you need to know that that means that the point 1 comma 2 is on the original function, and the point 2 comma 1 is on the inverse function. We need to now take the derivative of the function, evaluate it at 1. I keep emphasizing this because that's the key. You have to evaluate the function at a number that the problem does not give you. Once we get that answer, we'll reciprocate that, and that will be our answer. So I now have to take the derivative. Did I do this on this slide or not? I don't remember. I need to take, I did. So now I need to take the derivative of my original function. I need to take the derivative of x plus 3 over x of f of x equals x plus 3 over x plus 1, which should be a fairly straightforward quotient rule. So again, let me cover this up so I don't see the whole thing at once. So I think I quotient ruled this. This is, and again, you know the quotient rule. This is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Gotta make sure you're keeping that quotient rule correct. I distributed a minus sign up top. I got x plus 1 minus x minus 3, which simplified to, I believe, negative 2 over x plus 1 squared. See if that's what I got. It is. So there's my derivative. I'm going to evaluate that at 1, not at 2, but at 1. So I just plugged in 1 here. I got negative 2 over 1 plus 1 squared. Turned out to be negative a half. That's not my final answer. If that's the slope of the function at 1 comma 2, then the slope of the inverse at 2 comma 1 is the reciprocal of that. So if f, and again, half the battle is getting comfortable with the notation. If f prime of 1 equals negative 1/2, then f inverse prime of 2 is 1 divided by negative a half, which turned out to be negative 2. So again, let me summarize. You're going to be given a function and I think the book says a, like it says, find f inverse prime of a. So it'll give you a function and a number. You have to know first, and the problem will not tell you this, that you need to know what x value goes with that number that they give us. The number that they give you is the x coordinate of the inverse, but that's the y coordinate of the original function. We need the x coordinate. So take the number they give you, set the function equal to it, and solve for x. That's still the key number. Once we and in this example, that number was 1. Once we have that number, take the derivative of the function, evaluate it at that number, and then take the reciprocal of that. So the math is not difficult. The notation is easy to get confused. So having said all that, your assignment is, in fact, that page 186, numbers 1 to 10. Now, in the book, the instructions say verify that f has an inverse. They all do have an inverse, so you don't need to worry about that. I think the instructions say verify that it has an inverse and then find f inverse prime of a. I'm telling you, just find f inverse prime of a. So that is it for section 2.6. I will tell you there's just one more section in chapter 2 that we're going to do, 2.7, which is going to lead to a quiz, hopefully by the end of, before the holiday break, we might guess. So have a great Wednesday if it's Wednesday. Don't forget to reach out if you ever have any questions. See you.